Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one's entitled, "The Simulated Sun is a Reflection of a Parabolic Mirror in the Sky." Now, figure 1 below shows what seems to be a huge blue parabolic dish in the sky. Its thin circular edge can be clearly seen amongst the cloud around it. The edge is jagged and even bent in one place. It seems to be bent up there. Because it is in the clouds, it will be at cloud altitude. And because it seems to be so clearly visible from what appears to be a window, it is most likely at a low cloud altitude. In other words, at about 2 to 3 miles above sea level. It is huge, most likely 500 to 1,000 feet in diameter, perhaps even larger. The surface seems to be very smooth, almost mirror-like. In other words, I think it is a mirror, and you may look at Article 749 entitled "Huge Artificial Screen Inside the Earth's Atmosphere." So, a parabolic mirror in the sky is most likely used to project the sun and perhaps the moon. And indeed, if we look at the photograph shown below, which was taken by Scott Sion of the sun, it looks like what you would expect to see when a very bright light is reflected off a mirror. So if you've ever seen a bright light being reflected off a mirror, you can see that this is what it looks like. The reflection is not perfect in all directions, so you end up with these beams coming off the mirror, and this is what you get. And you can see this is actually a blue light because it's blue at the outer edge. So it looks white because any light that's bright enough, no matter what its color, will look white just because it's very bright. Now, this means that the sun that we are seeing in the sky is actually produced through a beam being projected onto a mirror. And the sun we see is simply a reflection of a mirror, which is inside the Earth's atmosphere, which explains why it seems to be so close. The mirror seems to be concave and thus converging. Concave mirrors produce real images which would be seen in space in front of the mirror, and virtual images which are magnified when the projector is closer than the focal point of the mirror. If the projector is placed at the focal point of the mirror, then both a real and a virtual image will be produced, and the virtual image will reach its possible maximum size. So it will be as large as it can get. The real image will then be very far from the mirror, but there will be a real image in space in front of the mirror. Thus, the light we would see reflected off the mirror would look much larger than the light coming off the projector, which must then be quite close to the mirror, i.e. at its focal point. And here you can see one of these devices in operation. You can see the simulated sun, and this would be the reflection of the mirror. You can see there's a white triangle there. You can see several devices around this light source, and these would be projected onto the mirror as well. So these look like lens holders or beam stabilizers, something you would associate with lasers. So it tells you that the beam is produced with laser technology. Now, the devices around the hexagonal bright light can now be explained as they are a reflection on a concave mirror which magnifies the image it produces. So the devices look much larger than they actually are. Since no projecting device is visible, it is most likely cloaked. The white triangle seems to be a piece of screen hanging in mid-air onto which the real image is projected, so that it is not seen in the sky, since it would look like the projecting device. And you can see that the white triangle is aligned with the mirror. The mirror in this case, or the sun in inverted commas, was over here. You can see how small that triangle is. And then the mirror moves this way, and of course the projector is aligned with it. and moves with it. And then, so it's now facing the camera. So the mirror here is facing the camera. You can see the triangle, it moves then from here to there and moves closer to the camera. That's why it looks larger. So the mirror moves this way, the white triangle moves this way. So this white triangle appears to be a small piece of screen, and they place it there so we don't see the real image of the projector, because it would most likely appear here, and it will show exactly what it looks like. And so they don't want us to see that. So they placed a screen here so that image is projected onto the back of the screen so we don't see it. And you may look at Article 724 entitled "The Sun is Gone, Simulate a Fluctuating Devices Around It" for more details on these images. And the projector itself, we don't see it. It must be quite close to the mirror. It's most likely cloaked, so we don't see it. But here's another one. It doesn't appear to be exactly the same model of projector and or therefore sun simulator that we have here. This one seems to be red, and this one, well, this one looks red as well. So it may be the same one, but they have graded it by adding the screen, because here we have the real image of the projector. So this is the real image of the projector. This is this would be the mirror. The projector would be here close to the mirror, and this is what we see. This is the reflection of the mirror. So the larger light source here is the simulation. It's aligned with this image of the projector, the real image of the projector. This appears to be one of the stellar cores in the sky, and they were trying to use this to hide it. You may look at Article 653 entitled "Planet X in the Sky over Canada and the Projected Sun" for more details on that. Here I'm mainly interested in this, the real image, which shows us what the projector looks like. And this is a ray diagram which explains how the virtual image would be formed. So this would be where the projector is. It's most likely actually here at the focal point of the mirror. And the focal point of the mirror is exactly between the center of curvature of the mirror. So that's there. And the mirror here. So they most likely place the projector right here, but this is easier to show the rays, to draw the rays, because if you put it here, it will be a very large diagram. So I've placed the projector here, and you can see how small it is, and then I draw two rays. One ray starts out parallel to the principal axis and then reflects off the mirror, goes out this way. The other one hits the vertex of the mirror. That's where the principal axis intersects the mirror. And it reflects off so that these angles are the same. And then where these two intersect, and you can see they diverge in front of the mirror, so no real image in this case forms. But if you extend them backwards, you see they intersect there. So they intersect behind the mirror. So this is a virtual image, but it's much further from the principal axis than the object. So it will be magnified. It will be much larger. And if you then place the projector here somewhere, these two will converge and you will get a real image. If the projector is exactly at the focal point, you'll get both. You'll get a virtual image very far away, it'll be very large, and you will get a real image very far away from the mirror as well. So you will get both, and that's why they placed that screen there, so we don't see that real image just in space in front of the mirror. So in conclusion, the sun that we are often seeing in the sky seems to be a reflection of a concave mirror in the sky. The light seems to be produced by a projection device which has cloaking capability. A white triangular screen is being used in certain models so that the real image of the projector is not seen. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.